Hello, this is the model of the tank that we just described and discussed it. This is implemented in SolidWorks recently, and in this tank we can mix air and hydrogen, air and oil together. But in the reality, this is very hard and very risky. To understand this geometry of this tank, we can cut it from the middle and see the geometry. This is the top part full of air and the bottom part full of oil. And then to start this analysis, we have to create this, we have to initiate environment with the flow simulation itself. So we can start with wizard, as it says here, and it's environmentally scripted. And after we save this project as a project 2, and then next, and we can see the system as SI. As usual, we take this temperature, although it's not required. So next, will be internal analysis. In this case, M-dependent one, it's transit analysis. We have to depend on time equal to 10 seconds. And then we will see the result after the slope 1, after 0, 0 second. Also, the gravity is involved. And then along the G will be 9 point, and the Z will be 0. And also free surface technique, oil and air. Next, oil. In this case, we will consider the oil bottom. This is in different stages. We were mixing oil and the air. It's a heterogenic mixer. Then we go to the next. This is default world condition. And then we can see here thermodynamic parameters. It's not that important in this case. And then we go to the temperature, 12 degrees. The initial concentration of inside this container is air. We will finish this, and then we can see the computational domain. It's considered the top part with air. The bottom part is not considering. What we will do here, we will enlarge this computational domain. We will edit this part and make the domain a little bit bigger. We want to include some pop-in also. See, domain is ready here. We can check the size as well. Okay, we can after hiding this domain, after that we define the solid part, oil. We can be done this from the condition, like initial condition, and then we have to define the solid part. The solid part is name of the solid part. We kept it as Endel 1. Okay, selected. It's to be disabled as solid component. Then we have to consider this like open liquid. We will not change any volume, because initially when the tanker is rest, there is no relative motion. And then we can check here, it's done. And here in this case, we don't require much changes in boundary condition. But one thing we have to do, if the car is moving in any condition, can be defined from general setting itself. We can do it earlier even, like acceleration and the gravity here. Acceleration to the gravity downwards. In this case, let's say car is moving in X direction, we will change the X component with some dependency. The vehicle can move in constant ocean. We can see here the result in better way. Let's define the movement of the tanker here using the graph. At the time is 0. The time is 0. When time equal to 0 to 2 seconds, let the acceleration will be 5 meters per second square. Or when the time equal to 3 seconds, let's say it will be the same acceleration 5. On the 4th second, let it coming down to 0. and the acceleration will be, the value will be 0 meter per second square. And then, as we consider this as 10 seconds, it will move after 10 seconds. 4 seconds onwards, it will not have any kind of movement. The value will be 0. Then we can see the curve initially, it has 0 acceleration. After 2 seconds, it will be moving 5 meter. Then up to 3 seconds, it will move same acceleration, and then it will come down to 0. And then from 4 to 10 seconds, again, it will continue at the same value. It's defined, applied. Okay, now everything is ready. Then the next step, we will apply some goals and set some goals, and all the goals will be as a global goals. Okay, let's go for the goals. Insert global goal. We will see a lot of things here: velocity, dynamic pressure, and we can see here dynamic pressure as well, velocity, and then average turbulent energy, and the torque. The supply chain effect is torque in this case. And then we'll see, yes, torque and different, we will check this. And then we'll go to the mesh to have better result. That's why we'll have better mesh. Let's see the global mesh here, and go for manual one. Yes, let's see display of revealment. It's not that much of event, but it's at level 1. But we can make it more. We can go more stage, more revealment. Yeah, because it says, yeah, now it looks good. And then let's define it in pressure or average velocity or energy, or we can do it in torque as well. Also, we can do it in the fork as a goals. We can do the goals on all these. Okay, this is different goals. And then before the starting, we have to start calculation. Like the PAD caption, you can see that here, M silver air and M silver purple, and volume pressure. Yes, after we selecting from here, done. Next, then we will run it, and then we go to the new calculation. We'll start. Run. It will start a new calculation here. Mesh preparation is going on here in this case, but we'll see it whenever it's finished. But further analysis with the weapons, we can see the result, like everything done with the pressure 53 and the turbulent energy 0.26, loss packaging, average velocity 0.002, and the force 9.06 kilonewton. This is the result obtained from our calculation. And sometimes, because it will be hard to see the result by numbers, so that's why we're having the graph or the social effects. Okay, let's go for the front view. This is the front view. We will start transition. We will see the propane and the air to be seen. That's where we can see it. Okay, let's go to insert cut plot, and then from the front we will see the M7 propane. Let's dynamic propane and the air mixer. Okay, we can see here the movement of oil and the tanker, but after 10 seconds we can see the behavior inside the tanker, and the top part is full of air, and the down it's oil. So this is because of this solution effect, some kind of forces in the tank, And this is the possibility of having some accidents. And then go to the next part, volume fraction, or the mass fraction, proper in the air, we can see it. Let's go clear, put one, clear and hide. Next one, next time we'll see the other cut plots. Then we go to the front plot, yes. Volume fraction of propane, let's see, okay, yes. I know it's a nice color, but here we can see the movement, and we will consider we will care about, let's not care, but we will initial the red part, propane, and the blue part is air. And the, in between, it's mix air and propane. Yes, this is how it moves in the tank. And let's clear this part. Then we will see something like a cut plot 2. We will go and clear and hide for the next plot. Next cut plot will go front. Let's see the velocity and along X direction. Okay, start here, yes. Here we can see the velocity in X direction. See the turbulence in, it's clear. So this is not clear as the first one. And then let's go to see our goal plots, and all the things that we have selected. Okay, we'll go here, then we show. Okay, this is, we already seen this on the window from the history and the graph in the previous. We will see the most important part here is the torque. See, the torque here is very high, because this is the caution effect. It's 80,000, very hard. 80,000, and downside around 35,000. This is the torque. And with the design, in this design, we have minimize it. Okay, and then we will close this and go to the trans expression is off and different. And okay, now we will go to the different analysis, and then we will model this analysis here. We can make it clone and modify the design here and rename it this project as project 3. And because everything is copied, we will do this analysis in baffles. And the project, and this new project, I'll call it project 3. Okay, let's go geometry and then make the baffle. Let's select the front pane and let's start sketching with the baffles. In this case, we not consider any baffles, just to see the behavior and the different between them, the like general type of baffles. Let's make it wide 2000 millimeter and recheck. Next to this, we can make similar type. It's like both sides we have to do the same. Offset. We will select the line, offset, edit, select, and then it's like suppose we supposed to make the same line 1000. Okay, here done. Check. Select again. We're going to repeat this select offset entity. We can make it also by direction here, as shows can be done. Like here, select again, offset entity. We will make it in other direction as well. Again, select, and then offset entity, other direction. And we go to select offset entity here. Yes, okay, so we have met the requirement. So it's enough now for the bubbles, almost 1000 millimeter. And now we go into the thickness, find baffins. Okay, we now exit from the sketch. And then, yes, we will select different section of view. we will cut it from different pen, like right here, yes. If we grain check here, it shows we will put some thickness on this buffle. Okay, after selecting all this line, we'll do features. We're not merging this rigid, but just we'll make it to the body. And this, you can see here, that we can change the direction by changing the direction, and even direction. We can second direction also. We can do it on the both side, apply up to the body. Okay, let's select this side as it shows here. Okay, green check. Okay, it's done now. Okay, so it looks nice. Buffle submitted already, completed, and then we have to cut it, cutting from the front plan. And this is the buffles. Now this is modified design, the buffle. We can see the solution effect, and that we can see the different result in torque, turbulent as well. And finally, you have to compare it. Which design is better to reduce the risk? Okay, let's save this tank with buffles. Then we have to go to the analysis. This is project number 3, and all the things we have copied, we're not changing any parameter, and we're not changing any input variable. Everything will be the same. Also, with a different design, we can run it. Okay. We can start a new calculation, mass refinery going on. Now we will see the result, and then we will compare it between the previous analysis. Okay, now it's done. Now the most important part is the torque. See, the torque is very less. It's only 600 Newton. Yeah, we can see the result from the cut plot to compare as well. Okay, let's close this and see the result in cut plot. Okay, this is a cut plot. To start this, we have to select the Explorer. We can drag this down and make the tank a little bit bigger, so it will be good for the solution effect. And from the cut plot, we can see. Okay, now we can insert the cut plot, immiscible per pin, as we saw from the first one. Okay, let's play. I just put it in different color, and now we can see. Yes, it looks. It's moving, and it's visible. Effect it little bit minimize, but we can see in this buffle design we reduce. Okay, let's clear and hide and see better result. Okay. And okay, yeah, you can see it with different colors. It's reduced a little bit from the previous one. So we can compare this result and select better design. We can do the cut plot 5 here, clear and hide, and even the Transit Explorer, we can put it off to compare all this result. That can be done from Excel, or we get it from result itself, the plots that we did. Okay, let's go and compare the result. Okay, we're going to compare project 2, project 3. We will work, and yeah, goal. Okay, we'll see the goal plots, and now we will insert our goal plots to see all the result. Okay, this is the result we already seen in our SolidWorks, and here this is the history from the graph. as we saw it. Okay, we can see here the torque and everything. Okay, let's even the torque minimized here, and the upper region approximately 2500. And all this result, we can compare it side by side, both analyze result side by side. Let's do it for the comparison result, and then we go to the compare, and we go to the project number 2 and project number 3. Okay, this is goal plot 1, goal plot 2, and then we will compare it. Okay, you can see down, it shows that it's comparing. Okay, here is the comparison in the form data. It's better to see it in a graph. Okay, let's compare this result. Okay, now it shows the blue it's project 3, and the red, and okay, no, this the blue it's project 3. Let's see the dynamic pressure in project 3. The baffles, maximum pressure 500 Pascal. In case of initial simulation, the maximum pressure was 357 Pascal. The turbinate energy, let's see the turbinate's energy here. The second one is very high. The first one was very less. To analyze this, we have to depend on pitching effect, which is torque. And the torque is very high comparing to first one. And the torque value was 77,000, around 77,000 in the upper region. In the down region, it was 32,800. But in case of baffles, the torque value minimized. Okay, so we can see here the force result as well. In case of the baffle, okay, it was compared to the other one with the baffles, and this is the result next to this is the result and the study that we can make it in and take more time. So that's why the SolidWorks and the CFD allowed us to do the experiment in very easy way. And this is the baffles, and this is from this comparison. Sure, we need the data to design a data in better way. So the data, as much as that we need a data here to clean and clear everything. Thank you very much.